Hey everyone, this is my assignment 2, Semagogo. Right now I'll just run through the game and let's see how it plays. So I wrote it in Lisp, and what you can do is just type start to begin, enter the number of plies, I'll do 3, and then enter 1 through 9 to drop a piece. And as you can see, the AI is functioning. Run through really quick. Let's see if I can beat them. Random numbers all over. And if you enter the wrong number, you just enter a new column. So the Minimax, and I happen to win. Alright, so let's continue on to the next part. Show how I implemented Minimax. Okay, so this is Lisp, so get used to all these parentheses, but this is the main Minimax function right here. So it's just the standard Minimax algorithm. First we check if it's 0 depth or if the board is a terminal board. If so, then we just return the score of that board. Otherwise, if we're maximizing the player, then what we can do is we map out the boards that we generate here to hash values, and then depending on which one's the best, that's the one we choose. So to answer the question about how the values percolate up the tree, during every iteration of this, what we do is we set the best value equal to whatever the column. Let me restart. If we have set the best value, so far if this is the best value, then we also set the best column to be this one. And then as we go up the tree, we choose the best column to choose from in that situation. Let's see what else. So of course I didn't implement alpha beta pruning, but I can explain my code a bit more. Actually I did skip over the modeling of the game board, moves, and scoring. So the game board is just a standard Lisp list. So this is the initial board, which is generated right here. So generate board is called, and what this does is generate a board like this. And then I have a function to print it out nicely. Initial board, and that's it. So we have a 9x9 board. So as for moving, what I do is during every turn I will check if the column that is being placed is valid, and what that does is basically check if there's any more space in the column. If there is, then we just add the piece to drop onto the bottommost row. Using Lisp, it made it very nice, just using lists functions. For scoring, I have this function right here, which gets the score of a particular player, and what this does is iterates down from the top of the board, from the top left. It checks first if pieces are to the right, which then adds 2 to the score. It also checks if anything below this is equal, if the 2 tiles are equal, and then it also checks on diagonals, and that's what all of these if statements are. And I do note that, of course, it can be optimized a little bit right there, but otherwise it runs pretty well. Alright, about 30 seconds left. So yeah, it seems pretty efficient. Lisp was a good choice for this. Getting my feet wet with Lisp and learning a lot about it, so I hope to continue using it moving forward. Thanks for watching.